Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems from the question paper CSIR National Eligibility Test July 2025. In this video, we discuss the solution of a problem from the section Real Analysis, which is related to one-to-one functions and onto functions. This question is placed in part B, which is a multiple choice question, and it carries 3 marks. The question ID is 56295498. Right. This question is suitable for all these examinations. Right. The given question is, let A and B be non-empty subsets of n, the set of natural numbers with cardinality of A greater than or equal to 2. Let S1 be the set of all functions f from A to B where f is 1 to 1, and S2 be the set of all functions g from B to A, which is where g is on 2. Right. So S1 is the set of all one-to-one functions from A to B, and S2 is the set of all onto functions from B to A. Which of the following statements is true? We are given 4 options. Option 1, if A is contained in B, A not equal to B, and B is finite, then there is a one-to-one map from S2 to S1. Option 2, if B is equal to n, the set of natural numbers, then there exists a one-to-one map from S2 to B. Option 3, if B is equal to n and A is finite, then there exists a one-to-one map from B to S1. Option 4, if A is finite, then S2 is finite, for any B. Let's now discuss the solution of the problem in detail. We have A and B are non-empty subsets of the set of natural numbers with cardinality of A greater than or equal to 2. Given S1 is the set of all functions f from A to B such that f is 1 to 1, and S2 is the set of all functions g from B to A such that g is on 2. For a function f from x to y, where x and y are sets, to be 1 to 1, then we must have the cardinality of x less than or equal to the cardinality of y for 1 to 1. Cardinality of the domain is less than or equal to cardinality of the codomain. For a function g from x to y to be on 2, we must have cardinality of x is greater than or equal to cardinality of y. That is, the cardinality of the domain is greater than or equal to cardinality of the codomain. Yes, these are true, but the converse is need not be true. Agreed. Now if order of x, the cardinality of x is m and the cardinality of y is n, then the number of one-to-one functions from x to y is given by npm, number of permutations, npm, out of the n elements, m, taken m at a time. So npm are the permutations, the number of permutations, which you are very, very familiar. Npm is n into n minus 1 into n minus 2 into etc. n minus m plus 1. Right. The number of onto functions from x to y is sigma k is equal to 0 to n minus 1 to the power of k into nck, where n is the order of the cardinality of the codomain, and into n minus k to the power of m, where m is the cardinality of the domain. Right. So this is the total number of functions and total number of one-to-one functions, and we are going to use these results, these all the 4 results in our discussion. Right. We are given A, B are non-empty subsets of n and the cardinality of A greater than or equal to 2. We are given S1 is the set of all functions f from A to B, where f is 1 to 1. Let's call on option 3. If B is equal to n and A is finite, then there exists a 1-to-1 map from B to S1. Right. Now, we have B is equal to n. We are given B is equal to n, the set of natural numbers, and A is finite, right? And the cardinality of A greater than or equal to 2. Let cardinality of A is equal to n, so naturally n will be greater than or equal to 2, right? Now the cardinality of B is equal to cardinality of n. Cardinality of n is equal to LF naught, right? Now the cardinality of S1 is equal to the number of one-to-one functions from A to B. Is given by the cardinality of the codomain P, the cardinality of A, that is cardinality of B, P, cardinality of A. Cardinality of B is LF naught. LF naught P n. Use the formula LF naught into LF naught minus 1 into LF naught minus 2 into LF naught minus n plus 1, and that is any number of times, LF naught minus 1 is LF naught only, LF naught minus 2 is LF naught only, LF naught minus n plus 1 is LF naught, LF naught, LF naught, LF naught multiplied is LF naught only, right? This is the arithmetic of the LF naught, right? So that means S1 has cardinality LF naught and B has the cardinality LF naught. Therefore, S1 and B have the same cardinality LF naught. Therefore, B is equivalent to A, or B is equivalent to S1, not A, S1. So that is, there exists a bijection from B to S1. I'm sorry, this is not A, this is S1. So there exists a bijection from B to S1. So when there exists a bijection from B to N, so there exists a one-to-one map from B to S1. So thus there exists a one-to-one map from B to S1. So that's precisely the option 3. Thus option 3 is true. Option 3 is true. And the answer to this question is option 3. And that is the detailed discussion of the solution of this problem. As this is a question that is placed in part B, only one answer is true, and that we have got it. Therefore, the answer is option 3. But however, we will discuss the remaining options in the next slides. Right, this is what we have. Now, we call on option 1. If A is contained in B, A not equal to B, and B is finite, then there is a one-to-one map from S2 to S1. Right. Now, given A is contained in B, A not equal to B, and B is finite, that means A is a proper subset of B and B is finite. So, A is a proper subset of B and B is finite. Therefore, A will be finite proper subset of B and B is finite. That means to say the cardinality of A must be strictly less than the cardinality of B and the cardinality of A must be greater than 2 and is a subset of N. Right. So, let A is equal to 1, 2. The set consisting of 1, 2 is a subset of N with cardinality 2. Cardinality of A is greater than or equal to 2. So, the cardinality of A is 2 we have taken. And cardinality of A less than cardinality of B. The cardinality of B must be greater than 2. So, that means we have taken B is equal to 1, 2, 3, 4. It is also a subset of N. Right. Right. Cardinality of A is 2. Cardinality of B is 4. Strictly less than. Right. Now, then the cardinality of S1 is the number of one-to-one functions from A to B. From A to B. That is, the cardinality of B is 4, cardinality of A is 2, therefore it is 4p2. 4p2 is 4 factorial by 4 minus 2 factorial, and when you simplify, you get the 12. Order of S2 is the number of onto functions from B to A. And now B is 1, 2, 3, 4, that is cardinality is 4, and A is 1, 2, the cardinality is 2. Right. The formula is sigma k is equal to 0 to n minus 1 to the power of k n c k into n minus k to the power of m. In this case, n is 2, m is 4. M is 4. n is 2, cardinality of A, and m is the cardinality of B. Right. And k is equal to 0 is substitute. 2 minus 1 to the power of 0 is 1 only. 2 C naught into 2 minus 0 to the power of 4 minus k is equal to 1 minus 1 to the power of 1 is minus into 2c1 into 2 minus 1 to the power of 4 plus 0. So, this will be 2c naught is 1 only, 2 minus 0 is 2, 2 to the power of 4, this is minus 2. So, the number of, so that will be 2 to the power of 4 minus 2, that is 14. Now, what we see is if there is a one-to-one map from S2 to S1, we must have the cardinality of S2 must be less than or equal to the cardinality of S1. But here, the cardinality of S2 is 14, which is strictly greater than cardinality of S1. So, there cannot be a one-to-one map from S2 to S1 because the cardinality of S2 is strictly greater than cardinality of S1. Thus, the option 1 is not true. Agreed. We move to the next slide. We take the option 2. If B is equal to the set of natural numbers, then there exists a one-to-one map from S2 to B. We have B is equal to n. We have A subset of n, and cardinality of A greater than or equal to 2. And we have S2 is the set of all functions G from B to A, that is B in this case n to A, G is on to. Now, if we say the option 2 is true, we must have the cardinality of S2 must be less than or equal to the cardinality of B. Right. So, let A be the set consisting of 1, 2. And now, Now, cardinality of S2 is cardinality of the set of all functions g from n to a is the set consisting of 1, 2, where g is on to. So, note that every function g is on to, because set of natural numbers to 1, 2. So, onto every function will be onto except two constant functions, where one function is g of n is equal to 1 for all n belongs to n. That means all the elements of natural numbers sent to 1 constant, and that is not onto. G of n is equal to 2 for all n belongs to n. All elements of n are mapped to 2 by g, and it is not onto. And the remaining functions are all onto. So, therefore, the cardinality of S2 is, now find the number of functions from set of natural numbers to the set consisting of 1, 2, number of functions g from n to the set 1, 2, minus non-onto functions. How many? 2. So, these are counting of the functions. So, the number of functions from a to b is the cardinality of b to the power of cardinality of a. So, this will be equal to cardinality of 1, 2, that is 2, to the power of the cardinality of the domain, that is cardinality of n, minus 2. 2 power cardinality of natural numbers is LF0, minus 2. 2 power LF0 is C, the continuum, minus 2. C minus 2 is C. So, thus S2 is uncountable. Whereas B is countable. B is the set of natural numbers. We have taken. So, S2 is uncountable. The cardinality is C. B is countable. B is equal to n is countable. The cardinality is LF0. Therefore, order of S2, the cardinality of S2 is strictly greater than cardinality of B, because the continuum C is strictly greater than the cardinality of n, that is equal to LF0. So, what happened? The cardinality of S2 is strictly greater than cardinality of B, but if at all there is a one-to-one map from S2 to B, cardinality of S2 must be strictly is less than or equal to cardinality of B. But we got cardinality of S2 is greater than cardinality of B. Therefore, there cannot be no one-to-one map can exist from an uncountable set S2 to a countable set B is equal to n. So, from S2 to B, there won't be any one-to-one map. So, this tells you option 2 is not true. Agreed. We move on to the last option, option 4. If A is finite, then S2 is finite for any B. So, as in option 2, take A is finite means A is equal to the set consisting of 1, 2, and S2 is finite for any B. It says take B is equal to set of natural numbers. The same thing will work here. Then S2 will come out to be uncountable, but in this option it is given S2 is finite, which is not possible. Therefore, option 4 is also not true. So, this is not true since S2 is uncountable, not finite, as in option 2 above. As in option 2, A is the set consisting of 1, 2, and B is set of natural numbers, because for any B is its set, B is set of natural numbers. Then S2 comes out to be uncountable, but it cannot be finite. Therefore, option 4 is not true. Right. Summarizing all the options, the answer to this question is option 3. That is the detailed discussion of the solution of a problem from the section real analysis, which is related to the surjective and injective functions. Right. And this question is definitely an interesting question. and you have to use this 3 to 4 results. That is, what is the cardinalities of the domain and codomain when it is surjective and it is injective, and what is the count for number of injective functions and number of surjective functions. All these things I have already given to you, and it will be definitely, this will be an interesting question. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. This is my channel. Please subscribe my channel if you have not already subscribed. Yes, I am sure I will be meeting all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.